Hi everyone, today we're going to talk about calculating using additive inverse. Now for most of you, you're doing an amazing job on understanding what additive inverse means. And so this concept I would say is just a baby step harder, okay? We're just going to use the idea of the additive inverse or the opposite to do some calculations. So let's go ahead and get started. Again, please make sure you have these notes loaded into GoodNotes and that you're writing down the same things that I am. Okay, so again, additive inverse means opposite, the opposite of the number, just like we learned in our last concept. So our first example here, it says it is 6 degrees below zero outside. How many degrees does the temperature need to rise to get to 0 degrees? Okay, so you know what it's like around here in the winter when it gets very cold. So 6 degrees below zero. I'm going to just draw sort of a vertical number line here, or like a thermometer. This is how we think of what a thermometer would look like. So let's say right here is 0 degrees. Okay, so then 6 degrees below zero, let's count 1, 2, 3, 4, 5, 6. This would be -6 right here. Okay, I know that's a pretty sloppy picture. You guys are always better at GoodNotes than I am, so I'm sure your picture looks much better than mine. So we start at the -6 here, and to get back up to 0, we would have to go 1, 2, 3, 4, 5, 6 units to get back to the 0 that we were trying to get to. So how many more degrees does the temperature need to rise to get to 0? That would be 6 degrees. Okay. And again, that's because when we have additive inverse, we know that -6 plus a +6 would be equal to 0. Okay? Let's look at another example. This one is related to football. So Jay Cutler was sacked 15 yards behind the line of scrimmage. Okay, the line of scrimmage is the starting point when you start the play in football. How many yards do the Bears have to go to make it back to the line of scrimmage? Okay, so again, if you think about the football field, here's our big football field. Okay, and let's say the line of scrimmage is right here. Okay, he gets sacked 15 yards back. YDS for yards. Okay, so that's like they lost 15 yards on the play. Okay, so that's a -15. So to get back to the line of scrimmage on the next play, to get back to where they were, they would have to go a +15 yards. Okay, so the Bears need to go 15 yards. And again, that's because -15 plus +15 equals 0. Okay? Next, let's talk about the number line again. It says calculate -3 plus 7 using the number line. So I've drawn the outline of a number line here for you, but I don't have the numbers filled in. I just have the 0 in the middle. Okay, so when we're using a number line to add integers, we're going to start with our first number. So I'm going to fill in some of these numbers here. So this is going to be -1, -2, -3, -4. And when I go to the right, of course, it's positive. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Please, again, make sure that you number this number line in your notes as well so that you have the same thing written. We're going to be doing some other types of problems where the scale of our number line is going to be different. So I want to make sure you guys have good notes. So when we're using a number line to help calculate, we're going to start at our first number, which in this case is the -3, okay, which is right here. And now we need to add 7. So because we're adding a positive number, we're going to be going to the right on the number line 7 units. 1, 2, 3, 4, 5, 6, 7. So when I do that, I end up at the number 4. So the answer to -3 plus 7 is going to be 4. Now, some of you guys have already kind of mastered this idea when you've used our rules for adding integers or when you think about the hot air balloon, but we also need to be able to use the number line and understand how we would represent that. So when we use a number line to add integers, we start at the first number given. And if we're adding a positive number, we're going to go to the right that many units. And if we're adding a negative number, we would go to the left that many units. So in this case, -3, we bump 7 units to the right, and we get to a +4. Okay, let's take a look at this one. Says, what is the distance between 6 and -3 on a number line? So again, let's go ahead and put our units in here. 1, 3, 4, 5, 6, -1, -2, -3. We could continue on, of course, but it says between 6, so here's the number 6 on our number line, and -3. Here's our -3. And we want to know what is the distance, or how many units are between -3 and 6. So let's go ahead and count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, there are 9 units between 6 and -3 on the number line. Okay, and the other way that kind of mathematically, for those of you who want to see it that way as well, what we're doing is we're saying 6 minus a -3 equals 9. Okay, because the distance between that would be like subtracting the two numbers. So we're starting at the 6 and we're subtracting until we get back down to -3. So 6 minus -3 is equal to a +9, or 9 units. Okay, I hope that helps. For those of you who have already done subtracting integers, which was in in Common Core 7, you guys have already done that. And what we just did was keep, flip, change. Okay, so 6 plus 3 equals a +9. Okay, the last example that we're going to be doing is to add 4.5, or 4 5/10, and a -2 5/10 using the number line. Now this is the kind of problem where I've seen students make some mistakes, so make sure that you're really paying attention here. The thing that makes this a little bit confusing is the scale that we're going to use on the number line. Okay, because we're using because we have decimals here, the best way, I think, to set up our number line is to go up in increments of 1/2 instead of 1 whole, like what we've been doing on the other problems. So here's what I mean. Let me make this a little bit bigger. I'm going to say this is 0.5, or a half again, 1, 1.5, 2, 2.5, 3, okay, and then this is going to be 3, 3.5. Oh, I keep doing that. All right, sorry about that. I was having a couple issues there, right, making my number line. But if you can pause the video and go ahead and make your number line look like mine, where we're going up by a half each time. So 0.5, 1, 1.52, 2.53, 3.54, 4.5, and 5. Okay, so go ahead and do that. And then what we're going to do is, just like before, we're going to start at the first number in our problem. So 4.5, 4.5 is going to be right here. And then what we have to do is we're going to be adding a -2.5. Because we're adding a negative, that means we're moving to the left on the number line. Okay? But here's the part that gets a little bit confusing. We need to go 2.5 units to the left, but each unit is only a half unit. So I'll say that again. We need to go 2.5 units to the left on our number line, but as we do that, we're only going down by a half each time, okay, because of the scale of our number line. So we're starting at 4.5, and now we're going down a half, 1, 1.5, 2, 2.5. So this is where we end up, which is at the number 2. So if we use the number line to add 4.5 plus -2.5, we end up at a positive 2 for our answer. Okay, so again, the reason that we had to go down in that manner is because each of our units on our number line was only a half instead of a whole like it was in prior problems. Okay, so that's why when we make a number line and use the number line, the scale that we use is really important. We have to use the same scale each time. Okay, if you have any questions about this, please ask somebody in your group or let your teacher know. Otherwise, your note should now be filled out, and you guys can go ahead and complete the note check and move forward with calculating using the additive inverse. Have a great day.